Here we are dissecting this CBT Nuggets video from Jeremy Ciara talking about configuring access lists. And he says practice access lists over and over. In this video, 4 different scenarios are going to be covered. Access list scenarios. It is much more powerful when you come up with scenarios. You find scenarios, or a mentor gives you scenarios, and you apply what you're learning to those scenarios. Much more powerful. So this is the topology we're going to be working with, and below you have your access list. An access list will be applied to each scenario. This is the best way to learn, is to practice scenarios. First, some general information about access lists. As you can see in the scenarios, there are different types of access lists. You have your standard access list, your extended access list. But Jeremy wants to explain what is an access list. So what Jeremy's going to do, he's going to bring up a router so we can see this in the iOS, Cisco iOS. On the screen we're going to see router 3, Cisco iOS, router 3. Now Jeremy clears the screen for whatever reason, but he explains that to set up access lists you got to go into global configuration mode, config T. Now the command for setting up an access list is access list, and he explains you're going to need the help, Cisco iOS help. You're not going to remember all the pieces when it comes to access lists in the iOS, so use help, use the question mark. Now if you want to create a standard access list, you're going to type the numbers between 1 and 99. To create an extended access list, you're going to type the numbers 100 through 199. Now depending on what router you're using, you're going to see all these other numbers, but a lot of these other numbers represent protocols that are no longer used. Now in this video we're only going to talk about IP access lists, because those other protocols don't exist anymore anyway. But if you noted, there is an expanded 2000 through 2699 for standard and extended. Expanded. It is pretty incredible, but Cisco allows you to make hundreds and hundreds of access lists, and each access list can have thousands of lines in it. Now you can start with any number you want, but in the video we're going to start with access list 1. After hitting the question mark, you are asked, is this going to deny or permit? Or do you want to leave a remark? This first access list is going to be a deny access list. Remarks are there to help you describe your access list for easier troubleshooting. After hitting the question mark, you get the question, do you want to deny a host name or an IP address? Host name is rare unless you're using DNS. Your options are deny any or host a single address. Now what are we going to deny? We're going to deny 192.168.5.100. Now after hitting space question mark, it will ask you, what are your wildcard bits? Wildcard mask means, do you want to match the exact IP address? Now if you do want to match the exact IP address, you will use zeros, 0.0.0.0. This means, look at this, look at this, look at this, look at this. Exact IP address. Remember that with your access list you can get very granular. 255 means I don't care. 0 means exact match. So if you did 0.0.255.255, you would be blocking 192.168. With the rest you don't care. Remember that a wildcard mask is the opposite of a subnet mask. That's a good way of remembering it. So using the do command, Jeremy does a show access list. So he doesn't have to go into enable mode. And notice what's on the screen. Notice what you could see. What's being denied and what's being allowed. If you type in no access list, that deletes your access list. So if you do it again, when you do it again and you remove the 255s, you do 0.0.0, and it'll specifically deny the entire IP address. Now if you don't specify the wildcard mask, then the iOS will accept the return key as that specific IP address. So basically, the wildcard mask of all zeros, 0.0.0, is optional because you can deny the host you type in the IP address, and you won't even be asked for a wildcard mask with all zeros. There's more than one way to accomplish the same desired result. If you specify the host IP address, you don't need the wildcard mask. So there we see line 1 of the access list. Now we're going to go back into the same access list 1 and create a second line. This line is for permit. What are we permitting? 192.168.5.0. Put in your wildcard mask. Let's look at these lines now. When we do a show access list, the first line is deny, the second line is permit. Those leading numbers are just entry line numbers. So what we have here is a very basic standard access list. 2 lines, line 10 and line 20. Now at the bottom of this and any access list, there is an invisible implicit deny. This can be a tripwire for many people. Just remember, there's always an implicit deny. Implicit deny means if you're not on the list, you're not getting in. It's just like a bouncer at a club. Now that the access list has been created, this very simple access list, it must be applied. It's a separate command to apply the access list. The access list command is easy. Going back to the diagram, we're working with router 3. We need to know what direction are we working with. Now host 192.168.1.5.100, that's what we want to deny from this serial interface. That's the plan. We don't want any packets to come in this serial interface. Serial interface 0/0, that's what we're working with. So first step is to go into the interface 0/0, and then the command is access group. Why is the command IP access group? It is what it is. So once you hit enter, it'll ask you what number. So we used 1, so we will put 1, then hit question mark again. So now we get asked inbound or outbound. We want inbound. So we specify in, then we hit enter. So now the access list has been applied with the strange access group command. So let's look at the screen. Let's see what's being denied. See that? That's being permitted. And above that IP is being denied. Line 1 is 10, line 2 is 20. Now because of the implicit deny, we have severed connections, and we see that here on the screen. So we have 2 routers here that are neighbors, and they're not communicating anymore because of the implicit deny. So you have to be very careful with the implicit deny. Hello packets are no longer being received from router 2 to router 3. Because router 2 starts with 192.168.2 and not 5, the connection is being severed thanks to implicit deny. So the router relationship is gone until you remove this access list with the no IP access group command. So once the access list is deleted, then the EIGRP relationship is reestablished, as you can see here. So be careful with access lists. So let's look at the first scenario. The first scenario is use a standard access list to block host A from accessing host B. So we're going to block host A from host B. Host A is not allowed to go to host B, and you can see the path that it takes. And the IP for host B is going to be .50. So after doing some very simple tests, a very simple ping, we verify that we do in fact have connectivity between host A and host B. To figure out what IP address you have, you just bring up ipconfig, right? ipconfig, and on your DOS prompt, and you see what IP you have. So Jeremy set up this lab with laptops and wireless adapters to make his lab work, but he's going to do better than a ping. He expresses that he's going to do a trace route. Okay, and he wants us to ignore this wireless interface at the top there. It's just something he had to do to connect. The interface that's being used is the Ethernet interface. So host B is .50, and we're going to trace route to it, and he's going to do a /d, trace route /d, just because it's quicker. And we will see that it basically took the 3 hops, and those are very easily verifiable using the network diagram that Jeremy has made. So he goes back to the diagram and he verifies that yes, in fact, the packet took the correct path from host A to host B. He mentioned that host A is in a VLAN. I don't think that makes a difference here, but the trace route paints a picture of the path taken. So then Jeremy connects to host B. He does a remote desktop to host B, and from there he'll run a trace route to see the behavior of the packet travel. Trace route is better than a ping, so he does a trace route from .50. Once again, he does a -d to avoid Windows trying to look up resolve those IP addresses. So yeah, he verifies that in fact host B does take the correct path. So now connectivity has been verified. We want to block host A from entering host B. No packets from host A, please. Thank you. Now Jeremy makes an important point here. He says before configuring this access list in the iOS, draw it out on paper. And that goes for other configurations as well. Think on paper first. So the command, let's remember the command for creating an access list is access-list. And Jeremy picks a different number this time. Instead of 1, I think he's going to pick access list 10. And because it's a standard access list, it can only deny, well, he decided to make it deny based on source. So standard access list can only deny source IP address. So the rest of the command is host and then the IP address. Because standard access list is the most basic of your access list, all you can do is deny that host at B. That's what the command looks like. You cannot specify from where. That's extended access list. Interesting anomaly. If you have an access list such as this one that only denies, when you apply this access list, you are now denying everything. Implicit deny. Remember that? At the bottom of every access list there's an invisible implicit blanket deny. It's just the way that access lists work. They're very restricted. The router will look at the specific line and say yes, that host IP is denied, but then it goes to the next line, which is invisible deny implicit blanket, and says everything else also is denied. So this has happened many times to many administrators all over the world. They sever connections in their network. So you can't leave this standard access list this way. You have to follow up with permit access list 10 permit command. So look closely at this. There's a couple ways to go about this. You can do any, or you can type out 255.255.255.255. Both work the same. So you're going to permit any. Let's go back to paper. We like to think on paper. You want to nullify the implicit deny, so you have to follow up with a permit any. The other way of doing it requires more typing. You type access list 10 permit 0.0.0, enter, and then the wildcard mask of 255.255.255.255. Okay, so either way the router understands it the same. It's the same for the router. Except that one way is a lot shorter. You type in 3 letters, any. The other way, you type in 0.0.0.0, then 255.255.255 as the wildcard mask. See? But when you do the show access list, the router says 10 permit any. It translated it for you. It made it short for you. So next, Jeremy deletes the access list, both of them, 1, and then he deletes access list 10, because he wants you to visualize something. Where is it going to be applied and what direction? This is something that you should be able to see in your mind and draw out on paper before you apply it, because once you apply it, it sticks. Now we look at the diagram and we say, where can we apply this? Well, host A is connected to router 2. You think, well, we could put it there on router 2. Okay, but is that the best place for it? Because host A does have to travel through this 192.168.10.1, which is the default gateway for host A. Let's put it there. But as we will learn later, when it comes to standard access lists, this is not best practice. This is not the rule of thumb. If we put the access list that we created there, it will in fact accomplish its desired result. However, it will deny way too much. So that's a bad place to put it. Now what if you put it here on 192.168.2.1 on this out? Let's place it here. Well, it would also accomplish the desired result. However, it would also deny too much. Well, what if router 3 was connected to another router that connected to another network? Then you would be denying host A that network. And that's denying too much. You can accomplish your goal, but you're also denying too much. So where is the best place to put this access list, and in what direction? Well, if we look at the diagram, the best place is to put it at 192.168.3.1, Ethernet interface 0/0, and we want it out. This is the best place because it specifically denies host A from accessing host B. Unfortunately, if there are other hosts on that network, along with host B, they will also be denied traffic from host A. But with standard access lists, that's the best you can do. So Cisco recommends that you place standard access lists as close as possible to the destination to prevent blocking too much. Because a standard access list is very basic, you cannot specify source. You have to place it as close as possible to the destination. It's the rule of thumb. So this is why it's good to always think on paper. Have your topology map grab a pencil and eraser and work this out on paper. Your brain likes it. So now off to the Cisco IOS to actually configure this access list. First, Jeremy verifies he has connectivity with a simple ping command. Then he types in the access-list command, and the number he uses is 25. Okay, anything between 0 and 99 is considered standard. Access list 25, deny, host, then the IP address 192.168.5.50. So you gotta then follow it up with the permit, right? 25, permit any. So a couple of steps involved here, but they're not hard. This is standard access list. Now to help figure out what interface he's going to apply it to, he uses the show IP interface brief command, which is a very helpful command. So once you figure out what interface you're going to apply it on and what direction, you type it in. IP access group, the number of the access list, and the direction. This is why thinking on paper is helpful. It's very important to visualize. Hold your arms out and visualize the direction in and out. Router 3, this interface, out. That's where we're going to apply the access list, or the standard access list, to be most effective. So as always, Jeremy verifies his work. He goes and does a ping, and the destination is unreachable. So it worked. The access list worked. So we have achieved success with this access list. Host A cannot access host B. And show access list is a very easy way to verify what's going on with your access list. It even tells you how many times deny has occurred. In this case, 8 times, because the Windows machine pinged that host 8 times, and I think Jeremy pings it again, and this time it denies it 16 times. So show access list 16 denies, you see here. So each time Windows sends a ping, it must be 2 packets, because 16 total denies, and there was only 8 lines, 8 actual pings sent. So that must mean that each ping must contain 2 ping packets. So with that, scenario 1 has been mission accomplished. Ding, 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 ding. Ring the bell, you win. Okay, scenario number 2. Now this is an extremely common way to use an access list. Deny telnet, deny remote configuration of a router. Very popular. Why would you want to remove access from a certain host to the telnet access from a network to your router? Because Cisco routers let you try username and password combinations forever. You do not get locked out after 3 attempts, for example, or 5 attempts. So it's a good idea to block it. Many administrators will allow only a certain host to have telnet access to the router. Restrict all others. Interesting to note that Jeremy always pings a device before he attempts to telnet. This way telnet does not hang. I think it's a habit that he has developed. But there is connectivity between host A and router 1. This is where we're going to do this. Notice that this router has a login banner, and Jeremy here demonstrates that he was able to telnet from host A to router 1. We want to accomplish this per the scenario, but no other devices can be affected. Only host A and router 1 are involved. Now it is important to note that yes, we're going to block inbound traffic from host A to router 1 on the inbound interface, but we also want host A to access the internet. So that's very important to note. So ask yourself, how can we do that? Well, standard access list allows you to block only VTY ports. It's interesting to see that Jeremy uses an access server in his lab to connect all his devices. But so he's on router 3, and then he moves to router 1. So let us recount the steps, shall we? The command is access list, but you must be in config T, and then you give the access list a number. In this case, the access list is 70. That falls within standard. Always use your help. Always use a question mark. Get into the habit of using help, especially with access lists. It's impossible to know all that you need to know. Now, because this is a newer router, you're not going to see support for IPX access lists and some of the older protocols. Only IP. So we did see on router 3 support for IPX and other protocols, not on newer Cisco devices. Jeremy mentions that he's pulling random numbers out of the air. This is access list 70, but if you're designing your access list, you're going to go sequential. You're going to start with 1, then go 2. Keep in mind again that each access list you can have thousands of lines, and you can have hundreds of access lists. So you can really get granular with your access list technology. Now, Jeremy wants to demonstrate the remark command. The remark command, you're allowed 100 characters, and he likes to use all capitals in his remarks. This way he can quickly identify them. So in his description, he just writes, this will deny host A from telnetting router 1. It's very descriptive. So again, the command is access-list 70 deny. Then he's going to type the IP address and the wildcard mask versus typing in host and the IP address. So remember that 0.0.0 means look at this specific IP address. That's the wildcard mask. Then you got to follow up with a access list 70 permit any. Otherwise, everything else will be blocked. So run the show access list command, and you will not see the remark because this version of iOS does not show up here. So he runs the show access list command, but he does not see the remarks. So you got to do an extra step. Show run include access list 70. It will show up in the show run running config. So now the $1,000,000 question is, where do you apply this access list? Well, you can't apply it to the router interfaces, because if you do that, then host A will not have internet access, and that is not a desired result. So instead, what we want to do is we want to apply the access list specifically to the VTY port, which is something that is special to standard access lists. We go into config T and line VTY 0 through 4. We have 4 VTY lines. Now when applying your access list to the VTY lines, are you going to use the access group command, the strange access group command? No, you're not. You're going to use a different command that Cisco came up with, and it's called access class. Okay, so we want to apply this access list to the VTY lines. And it's access class 70. That's the number that we had. And then we want to deny incoming connections. So you type in in. Word to the wise, always use in. If you use out, you're going to have strange problems with your router. So 99.999% of the time you will use access class your number in, not out. Let's verify our work. Type show access list 70, and there it is. Notice the permit any. Now that we verify, let's test. Go to host A, try to telnet to the router, get out of the old session, telnet, denied. You will not be able to connect, so the access list does work. Interestingly enough, we go back to the router and we do show access list, and we see that yes, something has been denied 6 times. Okay, that host was denied 6 times, so there must be packets. 2 telnet attempts, 6 denies. That means that each attempt had 3 packets. For each telnet attempt, host A sent 3 packets. That's why you get 6 denies. So the scenario called for no other devices be affected. So can host B still telnet to the router? Because we only wanted to block telnet access to the router from host A. So Jeremy does a test. He goes over to host B and he telnets and he's able to get in. Interesting enough, when you do a show access list, the permits also show up. If you notice, there's 2 matches for the permit because B was able to connect. So scenario 2 is now mission accomplished. Telnet access has been blocked from router 1 to router 1 from host A.